So the stack is used to optimize some algorithm. In some algorithms, we can use stack to make it better in terms of the performance. So, for example, there is one problem, we call it computing span. So, this is not in the book. We can use stack as an auxiliary data structure in an algorithm. So this problem, yeah, we have an array. Let's say this is the array X, and we have the span. This is the span S of Xi. That is the maximum number of consecutive element Xj immediately preceding Xi such that Xj is less than or equal to Xi. So maybe it is a little bit complicated. Usually we use this one for the financial analysis. Let's say like this. If I have a number at the position index 0, the X is 6. So this is 6. Maybe if you know the stock, 7. In the stock, you need to know that if the price is down, then you can buy them. And then check until which part of the price you can sell. And then if it is already in the top, it will go down again. Then yeah, you can sell directly. So in this case, we also can use the algorithm. We call it the computing span. Let's say if now the price is 6 in the time index 1, so the price becomes 3. In the time index 2, that the price become 4. In the time index 3, the price become 5. And then in the time index 4, the price become 2. So we want to check if it is still high and then directly go down, then we will keep the span as it is. Or we can say the span should be 1. But if the J is higher than the last data, so 3 and 4. So 4 is higher than 3. Then we will do the addition. Next, 4 and 5. 4 is lower than 5. Then we will do addition. Next, 2. 5 is less than 2. 5 is less than 2. No. So we will start again the span from 1. So if the price is increasing, like this one, then the span will also increase. 1, 2, 3. So we know how many times then that the price increase. If the price getting low, then this previous price, then it will start again from 1. In this case, we can see the stock, how many times the price is in the top, and then yeah, how many times then that we need to wait until the price is high. We can have like this algorithm. So in this case, the input is an array x of n integers, and the output is an array s of spans of x. So s, it depends on the value of x. So using this pseudocode, it mentioned it is quadratic. You know, quadratic. Quadratic means we have n power of 2. This is quadrant. We call it the quadratic. At the first time, we want to assign s. So s will have a new array of n integers. So if we have array something like this with n numbers, then it means we will do n time. And then we will do this for loop from 0 until n minus 1. It means we will do again n times. S start from 1. Because this is in the for loop. So once this is n times, of course, this will be also run for n times. And then we have while s is less than I. So I start from 0 and then s start from 1. If s is less than I, so it is 1 is less than the index, and okay, this is the operator n. So if this one is true and this one is true, then we will do something. So xi minus s. So the position of index 0 minus the s. This is less than or equal to the x output. Then we will do s plus 1. So we will increase the s. So this is the algorithm to select this one. If this one is 1 and this one is higher, then the problem is done. Then we will do plus 1. So this one, we will check the s equal to s plus 1. Because this is while loop. So that's a possibility. Okay. We will do for one time. Then there's also a possibility to do it 2 times. And in the worst case, we will have n times. So this is n. This is the worst case scenario for this value. And then for every of this one, it will follow with this while loop. At the end, the s, okay, so the si, which is representing the index of the new array, it will equal to the s. So this is n time. Until we have n, and then this is another n times, then this algorithm span 1, it will run n power 2. Because this is n and this is another n. So n multiplied by n. And it is n power 2. we can do this computing span with stack. So we keep in a stack the indices of the elements visible when looking back. So we can scan the array from left to right. So we can scan from left to right. Let I be the current index. And then we pop the indices from the stack until we find j such that xi is less than xj. If we find it one, then we set the si equals to I minus j. Then we push x onto the stack. You can see like this one. In this algorithm, its index of the array is pushed into the stack exactly one time. So as it is the array of n integers, so we will do n times, and then A is new empty stack. So the new empty stack, it means you can just design, let's say if you use the array with stack, if you use array based stack, then maybe this is just one list. Okay. So we just have one operation. And then its index of the array is popped from the stack at most one. So let's say if I do again with the n times. Now we will check with the stack A. If A is not empty, do you understand meaning by this? This one. This, what does it mean? This is negation. So if A is empty, like this one, it means because we have the negation symbol here. This is if A is not empty. So this is in the pseudocode. So we can say this one. While A is not empty, that's the meaning. And X A at the position of top. So the X in the position of in the top, which is lower than or equal to the xi. So we just want to check only the last of the stack. If it is true, then so take the numbers from the stack. If A is empty, then we will do this one. Si equals to I plus 1. Else Si equals to I minus the A, or we will do the fraction with the position of stack at the top. And then we will do the push of the index I into the stack. If you look at this one, so this, well, we will do only n times following this for loop. And this pop, this is only one time operation. If you learn in the stack, we do the pop is one time, we do push also one time. If then it is also one time, this is an operation, we can just say that if it is inside of the loop, so it follows the end. Else, this is if this condition is true, then we will do this one. If the condition is false, we will do this one for n times. And this is also another operation inside the for loop. So when you use the stack, the statements in the while loop, this one, the statement in the while loop, it will be executed at most n time. So we have the span 2, we call it, this is on, because we have only one time for the loop, and this while we use the stack and the operation is 1 and 1. So that's how we can use the stack to make the algorithm more optimized. And in this section, you learn about the abstract data type. You learn about the stack example, how to optimize the algorithm using stack. Now let's move to the second section about the key.